So this is Reclaiming the Unexplored in Hypervisual Programming. I am Michael Homer. Should do that. We'll see how the title bears out as we go. So I have basically two arguments that I want to make here. One of them is that visual programming environments as they currently exist are too similar, are too samey, are too wedded to recreating the same models of programs, the same models of programming over and over in slightly different variations, but otherwise all pretty self-similar to one another. The other argument I want to make is that it should be possible to look at the same piece of code in different ways using different representations and to edit, manipulate, run, simulate that code in any of those, all within the same system. So it should be possible within one single system to look at the same piece of code in various different ways at different times. I'm going to flesh out those arguments a little bit, and then I'll show some pieces of a prototype I made that explores some of those areas, and maybe make the argument that this is actually relatively easy to do. First up, let's have a look at visual systems and what I mean by sameness. So there are a few common patterns that come up again and again in existing visual systems. One of them is the node and wire environments, so boxes with lines between them. Those lines are edges or vertices or wires or whatever, and that's a graph. It represents the control flow or data flow, or sometimes both, of the program. You edit the program by actually editing the graph. The changes that you make to the connections are changes to the control or data flow when you run the program. There are a lot of these systems. People keep making more and more of them. A few of them have taken off and had some relatively significant success. A big example would be Unreal Blueprints, but there are also some other more specialized things. You've seen things in LabVIEW, you've seen things in other cases as well, particularly sort of music, arty things sometimes. But by and large, those are tending to be too clumsy, too awkward, too large to really be practical. People keep trying them. This time will be different, and it's not different. Another common pattern is the sort of textual analogs. So I'd say block-based programs are a very obvious example of that, where what you're really doing is editing an abstract syntax tree of a textual language. And whether or not there is any actual textual language that you ever serialize that out to, you're going to eventually have something that is essentially a syntax tree. You're going to be editing something that is describing the program in the way that a conventional textual language can do. There are some other approaches that also do more or less the same thing. They don't present it in quite the same way, but where ultimately what you end up doing is changing the syntax tree of something that is a more or less typical backend bit of code there. Most of the time, what these do is they replicate the behavior, the model of the common, successful, popular, mainstream programming languages that you see people using in the textual world all the time. That means they're taking with them the general structure, the general semantics of those languages, and they're adding these visual things on top of it, which have their own costs, their own benefits, and so there are trade-offs being made there as well. Both of these common models are useful sometimes. Both of them do have value. What I'm going to argue for, though, is that we should have more and different things going on as well. We should have more varied presentations. We should have different views that are more dramatically different. We should have approaches to it that make more use of the full range of things that a visual system can provide that a textual system can't. So rather than just editing things by dragging shapes around, which is basically what you do for both a block-based system and a node and wire system, we should be using all of the available dimensions. So spatial layout can be semantically meaningful. We can use color, and we can use movement. We can use change over time in ways that a textual system just can't. We should be making systems that make more use of those things. And there are some of those that are around already. We should have more of them, and we should be using them all the time. We should have more varied semantics. We should be looking at different approaches to programming that a visual system can help out. So there are a lot of approaches to programming that have been tried in the textual world that have not been as successful as your Javas, your Pythons, even your sort of typical functional programming languages have more success than a lot of models. And it's interesting to think about why that might be and whether a visual system is able to compensate for some of the drawbacks that might have led to some of those systems not taking off to the extent that they might have liked. It may be possible to, in a visual system, cut off the limitations while still exposing the strengths, still exposing the reasons that people wanted to create and use those systems in the first place, So we can make use of those benefits without having to pay all of the costs. So for example, Forth is a language from the concatenative paradigm, called because you concatenate things together and you get a composed program. And those languages are sometimes known as write-only languages because while it's quite straightforward sometimes to write new code in it, looking at existing code can be completely incomprehensible because you have to mentally simulate the way the language works. Think about what are all these functions doing, how many arguments do they have, and if you get it wrong, then your entire understanding falls over. A visual system could present that in a more straightforward way, could expose information to the user that would make that more comprehensible. We can cut off some of those costs while retaining, hopefully, some of the benefits of it. We should explore that for all these different models and other models as well. There are lots of paradigms that have had no exploration at all. I think these ones up here, there have been some visual systems that have worked with them. There are other models that have had none at all, and we should be trying to explore all of those and seeing whether or not they're useful. At the moment, we just don't know because no one really tries it. That's my first argument. My second argument is that we should have multiple representations in the same system. So there are a number of block-based systems in particular that have a sort of parallel textual and block-based view that you can either switch between, like in Tile, Grace, and Droplet, or that you can see at the same time, like Polyglot. And there is some good reason and some research to show that just the mere fact of having two representations here is beneficial in some ways to the users. There are also other alternative approaches that don't look as much like code on each side, like the sketch and sketch on the bottom, that you can edit on both sides and again edit the code. These multi-representation systems allow us to have different interactions and different affordances provided to the programmer when working with the same code. You can take that tile grayscale at the top, you can edit it as blocks, you can edit it as text, you can go back and forth, and you can do different tasks in a different view if you want to. But when I'm talking about multiple representations, I'm not just meaning let's have 2. I'm thinking let's have 10 or 20 or more all in the same system, which will allow us to specialize, will allow us to have a much greater variety of different approaches explored for the same code that can be suitable at the right time. So why would we want that? Well, each one of those views can make its own different trade-offs. It can decide to foreground different aspects of the code itself, of the data the code's working on. It can choose to make different interactions available. It can give us the ability to make different changes, to inspect things in different ways, without having to commit to that, using that for the entire system or for all time. It means that the user can choose the right view for the task that they are trying to work with. They can pick out the particular view that helps for the particular thing they're trying to do. They can do the thing and they can move on and then not use it again. That means we can get a much wider variety of presentations all available without any of them needing to be quite so load-bearing. It'll be possible for us to try out some very special purpose views that have very specific reasons to use them and incorporate them alongside the other more generally applicable approaches as well. It's possible there'll be different audiences that our different views can work with that can also help us to make better use of our code and of our coding time if we have other people elsewhere in the organization writing code that are not programmers, but they need to understand what the program does. We can have a system that can present that in a more accessible way for them, maybe even a more editable way for them, potentially, that is still fully integrated with the system that the programmers themselves are primarily using. The other point, though, is I talked a lot just before about how we should have more varied representations. One thing that comes with having a multiple representation system is experimentation becomes cheap. Having new representations has much lower risk and is a much lower stakes proposition. That representation that I make doesn't have to be load-bearing. It doesn't have to carry the weight of the entire system. It can just be something that we try out speculatively. We can put it in there. It can be used for what it's good for. We can try to find out what it's good for. And we can just ignore it for the times when it's not so good. So we can explore a much wider range of things at a much lower cost and with less work, less risk. Any multiple representation system is at least as good as the best representation on its own, because if nothing else, we can just use that one all the time. But we can also have other views that can compensate for any drawbacks that best view has as part of it. That means we can uncover some hidden gems, we can include some limited purpose views that have very specific use cases, and that comes as part of the system, essentially for free. It's relatively cheap and relatively easy. I think that is a valuable thing that we should be encouraging and we should be exploring more of to allow us to explore more of the space in general. So that's essentially my argument here. What I'm going to show is a bit of a prototype that I made and some extracts from that prototype that are going to illustrate some of those arguments, some of those points that I've made here. This system has several representations in it. Maybe not all of them are good. In fact, almost certainly at least one of them is not good. But they're all there, and we can try them out, we can explore them, and we can find out whether they are actually valuable or not. It's a switchable system, so you have a program on the screen, you click a button, and you have the program in a different view afterwards. It works by animating those into place, so whatever is in both views will smoothly move between, so you know that this is the same element in both places. It has some quite contrasting paradigms, some varied purposes, some varied interactions that it supports. It's possible that there is a greater range of things that it can do there, but I'm going to show off a few instances that are going to cover a range of things that support the things I've been arguing so far. So here we have what is essentially a very boring concatenative language, a fourth-like language here, that is highlighting already some of the potential difficulty of understanding what's going on here. One of the difficulties is that you have to know what the arithmetical of the functions are, what the outputs are, what order they come in, all those things there. And in a textual system, it's just difficult to do that. But what we can have in a visual system is we can make this interactive. We can allow it to highlight that information to us, to show us where these arguments come from, where the outputs are going, and to offer affordances for inspecting the functions themselves, for inspecting what they do, for inspecting where they come from. We have that ability that we don't get in a plain text system. We could layer this on top of a plain text editor, and it would be fairly similar. We can also have a much more contrasting approach. So here we have a two-dimensional grid layout here, where the spatial layout is actually semantically meaningful. This is the same program as before. It's a little toy program, basically not a very good one, just so that we can use some of these features here. And it's going to show us that in the middle here, add is taking in 5 and 4 from above it, and it's producing 9 below it. So the spatial layout is actually showing the structure of the program and showing which values, which arguments are being consumed by what, which values are being produced, and it's showing the actual values themselves. We could also have different data coming in. We could scrub through that and look at different approaches, different results that came out from different input data as we went through it. We can also go a little bit further from this. We can switch away from this view entirely. This one is good for some things. It takes a lot of space. We could switch to a different view, maybe a view from an even less common concatenative paradigm that virtually no one has explored before, or back into our normal one again. We can also switch this out again into a sort of essentially a node and wire system. So we can pop over here and we can look at this as a node and wire system. Those do have value. They show things that other views maybe don't highlight as much. So they're not inherently bad. They're just often not great as the only way of doing it. We can see here some of these semantic trade-offs that I've made in letting those representations coexist. So in particular, we can see that all of those function nodes there, essentially they're in columns going across the page there. Those columns are the same columns as the rows of the previous grid view that we had before. And so the structure of this node and wire system enforces that we have our edges always going from left to right. It inherently layers these things so that we have the ability to have this wider range of views of the same code here. That's a trade-off. That's a cost that has been incurred to allow us to have all these representations together, but there's no actual semantic cost of that. It doesn't change what you can express. It's just a structural change in the way that we present it and the way that we store it. The different functions in the system can settle into different views. I could have one that was looking at things in this way, one that was working in the concatenative way, one in the grid way, one in any of the other views that are available here, and they could all interact as equals. They all interact under the same shared semantic model here. That means that we have the ability to settle different parts of the system with different users in different views, or different parts of the system that have different things that we need to do with them into different views, as well as switching between them at runtime for the same code. The semantic model here has a number of oddities as part of it because of the domain I'm working with for the broader project here. And one thing in particular is that it's possible for a function to have alternative results produced. So it can produce more than one result that then gets projected through the rest of the program, and we evaluate the whole program with each one of those alternative results. The idea being that we have potentially one column of data that has many things inside it. We're going to splay it out. We're going to see some examples of what we can do with that as well. But the semantic model as a whole is a compromise between a lot of different things. So there's a trade-off that's being made no matter what we do here, but we can make things that are able to cover a very, very wide range of different things. Maybe sometimes that range can be a little bit too wide. So we can also have this view here, which is one that people suggest when you describe the way that the graph layering and so on works. They describe it in advance. I made it. I've tried a few different versions of this. I'm not sure that any of them are good. It has the unusual combination of benefits of being both very large and conveying very little information. So this one quite possibly just is a dead end. But we can make these kinds of speculative explorations. It doesn't have to have the entire system rest on this one view being able to carry the weight of the entire programming system here. I can add this in here, and if it is useful for some audience or for some purpose, then it's available, it can be used. If it isn't, then it will probably wither away, maybe eventually it'll be taken out. But the ability to make these kinds of speculative explorations is, I think, a valuable one, and one that we should aim to create for ourselves, even if sometimes the things we make are more cautionary examples than actually valuable ones for ourselves. I'm not sure it's good, it might be. I think it's new. I think there might be a reason no one's done it before, but it's there, we know about it, we can see it, we can see and we can find out what's going on with that. One more special purpose view here. This one here is aiming for a certain kind of debugging that someone might do. I mentioned that we have potentially multiple results here. Now this here is, I would say, not a good design for a square root function, but for the sake of a tiny example, our square root function returns both square roots. And we can see that we have the program sort of forking. Each of these horizontal splits is forking into a different line that evaluates the rest of the program using each one of those return values here. If you're familiar with JQ, the JSON query language, that also works essentially this way. It's list monad, it's a bunch of different things here that you can look at in this kind of a style. This here is a view that is available as an ordinary view as part of the regular system. It's just an ordinary view of the code, just like all the other ones, but it's there for a particular special purpose. It's here to allow us to do some debugging tasks. And we can inspect it, we can interact with it, we can offer additional affordances as part of that, but it's fundamentally just a part of the program itself. It's not a different view layered on, it's not something we can explore separately, it's just one view of the same code we're working with the entire time. That offers some additional features for certain tasks that we might be trying to do at any given point. There are also some other views here and some other alternatives here, but I'm not going to dive into too much detail now. I'll finish though with a bit of a call to action, which first part is we should explore more. We should explore more even if the things we're exploring are potentially bad, maybe even especially if they're potentially bad. And I think in particular we should build multi-representation environments, not just because they're good on their own, but because they make that exploration easier and cheaper and safer for us to do. It gives us the opportunity to make more explorations without having to invest in the entire system for just that one model. Finally, just give it a go, make things, and then tell us what you found. Even if what you found is this radio view is bad, make it and then tell us about it so that we all know the radio view is bad. Because there are a lot of explorations out there that could be done that one of us might try to do, and then we'll discover, well, once we've made it, it wasn't as useful as we thought it might be, or it didn't turn out to be useful even when we thought it wasn't going to be. But try it, make some more things, explore a lot more of the space that these visual systems can give to us, and actually create them, talk about them, tell us, communicate with the world, and let us know what's available and what is and isn't a good idea in this world that hasn't been explored so far. With that, I'm going to thank you for your attention and invite any questions anyone has.
Trying to figure out how to turn, oh, it's on, okay. So having seen visual programming environments in my past lives with Smalltalk that have failed. And then when I was at Tech Labs or Tektronix trying to do visual programming languages, there's some things that they don't do well. And I just wonder if you've had some thoughts about visual ways of programming. One thing is scale. So I can see a tiny example and I can comprehend that, and I can, you know, from a student point of view, but I've actually seen really badly done visual programming environments where once you get like 400 lines between things, it's incomprehensible. So that's one issue. How do I deal with scaling and scoping? Because I think programming or modeling is how, an environment that supports visually doing that would be kind of nice, but at some point it's not just that you need to go in certain views, but it's the whole idea of programming that way becomes incomprehensible. So that's one problem about how do I navigate a larger program this way. Second thing is dealing with recursion and timing and loops that go back. And visualizing those things, particularly let's say if you're doing graphics animation or things like that, it's really hard to kind of visualize those. So I just wonder if you had any thoughts about those two kind of problems.
Yes, I think one thing that we can do for scaling is when we have multiple representations, it's possible that some of them can allow us to ignore parts of the program, can allow us to see some of those things at a larger scale without having to have the entire thing predicted. Like one of the node and wire issues is you have 400 lines, it becomes impossible. So that is a trade-off we can make between different views, but I think the bigger picture of it is I don't know that anyone has created the views that are good for that yet. What I'd like people to do is create them and tell me about them. So I don't know that part yet.
Fair enough. One thing that drives me nuts is like people who are in love with Prezi and they go zoom around. I get vertigo looking at that. So anyway, just don't do that.
That's good advice too. Yeah. I think that the ability to have different views is probably helpful for these things, but I don't have all the answers to that yet. What I'd like us to do is explore more, and I think that we've run into that problem and then decided not to carry on too much. And I hope there are better solutions to some of these things. One thing we can have is we can have text representations as part of this that can cover some of those things in a broader way if we want to.
Okay. I'm sure this doesn't surprise you, but the idea of having lots of different kinds of views resonated with me. My question is, how hard was it to implement those views? And the subtext is, can you imagine a platform or an infrastructure that would make it easy or cheap to come up with lots more views of the kinds that you were thinking of?
I think I might have seen one just before. I think that the cost of making an individual view here is not that high. I rebuilt the system and pretty much entirely since writing the paper. And I'd say making an additional view is something that I can do in a day or so, including all of the animations and so on, just happens. Building out the infrastructure to make that doable is more complex, but it's relatively easy to add new things into this if you want to. I don't think it's a high cost thing here, but it is work and it is a lot of fiddly detail doing layout and stuff. So it's still doing sort of graphics work somehow.
I was just curious because the example that you gave was like a numbers, obviously very pure functional stuff, and I was curious about if you've considered different visualizations for imperative side effect type stuff. Like you have in the examples you were contrasting against the beginning, you had like control flow, and then there's like alternative visualizations, like if you know state charts, they're like based on finite state machines.
Yes, and this, the overall bigger project here is essentially a data pipeline system. So it does have a forwards flow essentially all the time. So not in this model, no. More generally, again, what I want is for people to explore those things because I think that in particular control flow is just not something that these systems have dealt with particularly well, other than by falling back on basically what is text and what is a control flow graph directly. So no, I guess.
Hey, great talk. Do you see a use of views that you can't program everything in, but you could program certain things really well? Like a restricted scope so you can use better abstractions and things like that?
Yes, 100%. I would like that. I think it is basically a good advantage of a multiple representation system is you can have views that really are good for exactly one thing, and that's it. And you don't have to have the whole system built that way. And what I'm, I guess, arguing for is the ability to make those is actually valuable. That what we need to do at the moment is we make things that are good enough for everything, but not actually good at anything. and we can specialize more, and that gives us more opportunities there.
Yeah. Okay. Great. Thank you.
Well, I have a question. Marcel, do you want to come and set up? Well, so I love what you're doing here. It's really nice, and I love your call for 1,000 flowers to bloom. and I'm certainly guilty of having done these sorts of experiments myself. Maybe can I make just a suggestion, which is that the next step, I mean, it's great to call for more people to do it, but we have to have some sort of a context in which that happens. What's the next step after you have this? And maybe it's, look at the artistic world where people come together and do showings and then design crits for each other and things like that.
I would love that, but...
So, okay, well, there you go. That's your next step, right?
I'm not good at organizing things. Yeah, I think that'd be great. I think it would be good to have, to look at these things as more than just, can it do something specific, but can we think about the other benefits that come with it as well?
A place where we can look forward to coming and show these things to each other and give each other feedback, because, the serious professional programmer world is, until you're at scale, they have no interest, right?
Pretty much. I think that
So we
things
have to
like
have something
Live
else
and
to keep us
Paint
going.
kind of try to do that kind of stuff. Live actually does do that kind of stuff, I guess, and Paint always has the design critique stuff in there. But I think that it's hard to squeeze those things into both industry and academia. So something a little bit hybrid is probably required there.
Thanks.